and it'll drain the battery even if it's off. So just to keep, you know, maximum battery life, it's good to take it out.
I gotta take this with me and complete the whole thing then.
It's not too difficult. I trust you guys will get the point in a moment. So
You guys only have one?
yeah, this is the only one.
I think that's the same battery that we use in the Ballmaster.
Probably similar.
It looks exactly
Do we have
the same.
Do you have like the new blue one?
No.
The fancy one? Oh, okay. I'm not sure if they're specific, but pretty straightforward.
So basically, no particular test piece is needed, only the ones that are in the box.
Correct.
And every single one has different thicknesses.
Yep.
So it's the point of making sure what thickness you're inspecting.
Correct. And we already have the job, like the program stored in the machine.
Oh, okay.
So honestly, once you fire it up, it's just gonna start working.
Oh, yeah.
So
Does Arnaud want to come too?
Yeah, I said to him.
I'll show you basically what the deal is here.
I already told him.
You guys got a lot of stuff to do in here today?
Oh,
Eh?
You guys have a lot of parts and stuff today?
All right.
Not too much?
no, good. I'm not proud. You can take that. Sure.
This is Brandon. Brandon Arnaud.
Nice to meet you.
Nice to meet you too.
So. So this is coupling. No.
Coupling.
Okay, so pretty crazy little probe here. It has 16 elements, and it's basically firing at all angles at the same time, is the concept. So it's got a pretty crazy connector. So you just take the cover off,
Okay.
and you just snap the cover off here, and you just line it up, snap it in. Pretty straightforward. So, let's see, I don't know what the best way to do this is. It's right here.
You want to sit here? I could sit here. Here. I'll just stand up like this.
Okay, cool. So, you just fire it up like normal. Yeah, it's expensive, don't drop it. All right. Oh yeah. So everything on here is touch screen for the most part. So the box comes with a stylus. Try not to lose it.
Oh, yeah. Okay.
This inspection usually takes a lot of couplings.
Okay.
When I'm on the airplane, I just have like a pail with a paintbrush. You know,
Oh,
just
yeah?
Go and paint it on. Yeah.
Okay. It's good to know.
And clean it up. Okay. So yeah, it takes a little while to load up. This thing is a tank. But essentially, the job's going to be stored in here, and it'll actually be the job that's on here as soon as I turn it on. But
Oh, yeah,
I'll show
okay.
you guys how to load it up anyways.
Yeah.
But it's going to be on here right away.
So do you guys use this guy just for that job?
That's the only job I've done it with.
Oh, yeah. Okay.
What is the job?
Hey?
What job?
It's a job on scribe lines on a 737-400 for first air.
Yeah, okay, so here's your display. First, I'll just kind of show you how to load up the program. So if you come up here, this is the file name, 533007. I believe that's the task number. So you just select the file up here. You can click open, and then you'll get the list here, 533007, I believe is the task card, it
Technique,
probably
okay.
say on the technique. And you just press the check mark here, and it begins to load it up. Very easy. And so yeah, this was set up based on the technique. It tells you exactly how to do it with the omni scan. So essentially what's going on here is this is your normal A scan that you guys are probably used to a little bit.
Oh.
Okay.
Okay?
Sorry.
No worries. So yeah, this is your normal A scan that you guys are probably used to, but for the most part, you want to ignore this. It's not going to help you too much with this inspection specifically. This is an S scan, but it's a side profile of all these angles together, okay? So this blue line here is the angle of like a standard probe. You'll see how it's at 60 degrees. So what this line hits will show up on your A scan.
Ah, okay.
Right? So, but you could just change it to 70 or whatever. Again, I'm gonna emphasize to basically try to ignore this part of the screen. Just focus on the S scan. So one thing that you can do, which I like to do since I'm right-handed, is you can click on the screen, or somewhere in the black, and I'm gonna press skew right, and that's just gonna mirror it, just gonna flip it. So now, now for me, I can visualize it a little bit easier when I put the probe on here, how that beam is actually looking. So when I do this inspection, it's pretty straightforward. What you want to do is get your probe on the piece, and you really want to try and identify what a fastener looks like on the screen. So up here in the corner where it says gain, you can select it, and then you can just change your gain with the dial like you normally would. And you can just do it on the fly. So what I like to do is I'll start scanning, and you want to try and lock down a fastener. If you guys have any questions, feel free to cut in at any time.
So how do you know that you have to change the gain? You go up or?
So you want to be able to. You don't want it to be too noisy. Obviously, you don't want too much of this blue background, but you want to be able to see a fastener at least.
When it's too blue, it means it's like it's a high lot.
Yeah,
of gain.
yeah, your
Okay,
gain's
that's
way
a
too
lot.
extreme.
Okay,
You can see your
okay,
A scan's
okay.
a little bit crazy.
Okay.
So for the most part, you can kind of lock down where the fastener is, and I'm gonna just change this angle a little bit. Hold on. Oh God, sorry. One moment. I don't know what I did. Where's the pen? Change this to 60. Okay.
That's 6.
Again, it doesn't really matter what angle you select on here, but I just kind of want to show you guys how the A scan looks like. So this is kind of something that you're familiar with, right?
Yeah.
Okay.
This is kind of what I use to give me an idea of where the gain should be. As you know, in most of these procedures, they try to ask for 80% full screen height, that kind of stuff. That's usually going to be your comfort zone. I even go a little bit lower. Joe will even tell you to go even a bit lower than that. So what I like to do when I'm doing this inspection is I'll go down the airplane and I'll figure out where a fastener is, and I'll figure out where the next fastener is, and I'll scan in between them, and hopefully you see nothing. Right? That's the general idea. Because it is a little bit hard to tell what the difference between a fastener on the screen and the difference between a defect on the screen is going to look like. But you can get them to light up quite nicely, actually. Let's see if I can get it. And on these test pieces, there's one defect right on the joint, there's one defect underneath the lap, and there's one defect on the shorter skin here. So one's a little bit closer. I believe this is the one that's closest to the probe here. You can get this one looking pretty nice on here too.
So the crack is the red, right?
Correct. So yeah, so I should talk about that too. Yeah, you're looking for red. That's gonna be your.
If we don't see red, you see dark blue or just blue.
That's fine.
That's fine.
Yeah, that's just background noise. Generally.
So basically, you want to see red rivet, nothing, red rivet,
Exactly.
Nothing, red rivet,
Exactly.
nothing, red
For
rivet.
rivet, it comes red too,
Yep.
right?
Yep.
Okay.
So I'll try my best to get this fastener a little bit better here. You have to wiggle it around a little bit, but yeah, essentially your rivet's gonna look like a red spot as well. And then you can even like walk it back. So it's as it gets farther away from the beam,
just like
it goes farther away. As it gets closer, it gets closer. Again, just try to ignore the A scan. Try to focus more on what's going on in this screen here. And you just scan across. So here's defect. That should be another rivet. Sometimes this one's a little bit tough to get. So you can kind of see it in there. So yeah, you get these little kind of like heat zones basically, these red zones
But what about this one?
So
What are
this,
these?
I believe that it's just picking it up from multiple angles. Again, this thing's scanning from 1 degree to like 90 degree or something. I
Okay,
forget what
so-
the range you can change it as. At.
Oh, okay. So if on the aircraft, it's really well. If it's nothing,
Yep.
all gonna be blue.
Yeah.
Everywhere blue.
Yeah, basically just blank. Like
Okay.
you'll
So you won't see here blue, but here you see like red. You
Yeah,
won't see
yeah.
that. Okay.
correct. Correct.
Okay.
So yeah, what I like to do is get really comfortable with what a rivet looks like, and that's kind of what I base it off of. Is if I can tell myself, okay, that's a rivet, get to the next one, that's a rivet, and scan in between and see nothing, I'm good. That's generally my attitude throughout the whole inspection.
Well, I mean between, you just put the probe between, and that's it. You don't have to scan like that.
Yeah, yeah,
right?
you scan
Yeah,
right
You
through.
scan.
So I
One
scan, I kind of like wiggle my way through.
Oh, okay. So if you go forward, you see the red of the
Yeah,
the rivet goes away.
It'll be closer to you, exactly. And again, it's not too difficult once you get your hand on it and get going. Between the different thicknesses, you might have to change the gain a little bit, but honestly, you
Like
could do it
usual.
on the fly on the airplane pretty comfortably. Like if I go all the way up to the 90 block, where I put somewhere.
Wanna try?
Yeah. Is that the one? Can I take a look at that? Yeah.
So that's the rivet, right? Right at that line. You got like that white
Yep.
line, so that's the rivet right there, right?
Yep.
Then nothing.
So
Wow, here you got something for sure, right?
Yep. And you can see the defect is very close
Ah.
to your probe. So if you pull your probe back,
Yeah,
you'll
it
see
goes.
it. You'll walk it out a little bit.
so you around that line, that's where you look at it.
Correct. So
That's
yeah,
it.
this angle line isn't really
That's it.
necessary,
Ah, I see.
but this
So
is
the
what
rivet's right
this is
there.
what triggers your A scan. But for example, if I didn't have the phase array and I had to do this inspection, I would choose a 60-degree probe because that's what this is telling me seems to be optimal. You know what I mean?
Okay.
Angle A scan doesn't really matter. What you want to look for is these red zones in this scan.
So right now, like let's say, okay, so this guy I get him really nice, right? The
Yep.
rivet right there.
Yep.
This guy get him nice. If I would want to get him a little redder, just bring up the gain.
Just turn your gain up a little bit,
Ah, yeah,
but
I see.
understand that your background's
Yeah,
gonna
I'm
look
putting in
uglier
more
too.
noise. Yeah.
Exactly.
Okay, I see.
Yeah.
Yeah. All right. Yeah. Got it. Got her.
So it's and if you want to try and go up to the 90 just to see what the difference is like, it's
Oh yeah, look at that crack right there.
there you go.
We can,
Yeah, feel free to
All right.
get the coupling going. It's again, it's not too difficult once you get going with it.
But I'm sure, like, if I would take the machine and the program would be at blank, then I would probably be
For
lost.
sure. So
But the fact that it's already programmed,
it's already in here, and I think if you read the technique, it'll actually tell you step by step. It says use an omni scan. Press this button,
Ah, okay.
and this has a setup wizard. You know, like kind of an install wizard for a program on your computer.
Yeah.
This has the exact same thing, and it's like a program where you put in the probe I'm using, the material
Right.
thickness, this and all that,
Okay.
and it just loads it all up for you.
And it okay, that's
Yeah.
cool.
And so the technique will tell you press the check mark button, press enter 230, press next, press this, press
Oh,
next,
yeah.
and it just
Okay.
walks you through it.
So that's cool.
So we went through all that and then saved it in here, just to
Okay.
make it easier.
So right here now, that's the rivet I have.
Okay.
When I go further, it goes further, right? This is it.
Yep.
It goes further. But again, that's the rivet comes
I
back.
think that's the multiple, or you're just pressed up too close to the.
Well, I'm going. It's
the line
right.
there.
that's the rivet.
Yeah, that should. be
Okay.
it
When I'm
right
going
there.
back, it disappears.
I think you're just getting the multiple right after, no?
Yeah,
I believe
okay.
so. Yeah, I think you can. If you go too far out, you can scan the multiple similar to your
Okay.
A scan here.
So now I'm right in the middle. This is it, right?
Yep, but you're basically right on top of it. If you see this defect is on this
okay.
shorter
Okay.
skin,
That's why.
your
So
probe is
that's
sitting
it.
on it. Yeah.
Okay. So when I go back again, I got the rivet.
There you go. And then this one should be a little bit farther out.
Yeah,
Yeah.
it goes further. Yeah.
Yep.
Yeah. Okay. It got rivet again. Oh, okay. I need to.
And then that last one is
Like this one, I don't see the rivet that.
should be able to pull it back a little bit.
I don't see the blue. Well,
Yeah, you kind of see
dark
where it
blue
should
there,
be,
but-
but it's not too blue. Yeah.
I would concentrate more on when you go on the aircraft and then just calibrate on the aircraft.
Exactly.
yeah, this is
And of
it
course-
again.
The paint thickness is gonna change a little bit here and there, but all you can really do is adapt and play with the gain until you can locate rivets confidently. That's what I try to do.
Okay, so if for the paint we have to add more gain, right?
Yeah, I'd add a little bit more gain for sure, and yeah, maybe expect things to be a little bit farther out than they are on the cow block, but not too much of a difference.
So when we go on the program, we turn it on. We don't need to touch anything. We
Correct.
just
it should be good to go. Since we've made some changes like flipping this and changing the gain, when you go to close this, it'll say, "Do you want to save?" And every time I just hit no, because I just want that original program
okay.
to load up. So you try not to overwrite it. If you do, it's not the end of the world, but you know, I just don't save it every time. And again, you can click on the screen and change the direction that this is going. It can go this way or whatever makes more sense to you. The one thing I don't know too well when it comes to like sizing a defect, I'm not very confident with it, but there is a way on this machine to use these lines here. And you
Sort
can
of like to calculate it.
yeah, so okay, so another thing I should mention is when you do find something and you're just scanning along, you can just press pause and it'll just freeze on that screen. So you could get off the airplane and go analyze that thing that you're looking at. I would recommend maybe going on YouTube, and Olympus has some videos on this thing where they talk about sizing defects and that kind of stuff. And they use these lines, so you can like select a line and you move it around and you see these units up here changing. Or sorry, somewhere up here. This is the scan time.
I think the little number right
Like,
under.
like these numbers up here. You can actually size a defect and say it's 6 millimeters or whatever.
yeah. If you see something like the red spot
Yeah.
with the rivet, so if you see something similar, you can almost
Identify.
guess how big is
Yep, yep.
the defect. Yeah.
Right. But there's ways to size the defects on this to like the millimeter. I've done a little bit of research on YouTube, but that was maybe a couple months ago, a little bit blurry now. But again, this machine's capable of a lot of stuff.
Cool.
And that's basically the inspection. I mean, there's not much else to it.
So then we turn it off. We try to turn it back on to see how.
Yeah, sure. If you want to do a full restart and see if you can get it going.
So I'm gonna take this with me in the cabin.